right, let's take a peek at fraction operations. In this first example, we really are in 1, 2, and 3 just matching it up with which one of these images goes along with the picture. Now, I like to use time a lot for fraction, addition, and subtraction, and sometimes other operations too, just because it's really relatable. So here, a quarter of an hour plus a quarter of an hour is a half an hour. And immediately I notice right here, here's a quarter of an hour plus an additional quarter of an hour to give half an hour. And I'm really thinking of this, so this immediately, my eyes are drawn here for number 1. But I'm thinking of this, when I say a quarter of an hour, I'm thinking 15 minutes. So I'm really looking at this as 15 sixtieths, or 15 minutes of the hour, plus 15 minutes of the hour, and 15 minutes plus 15 minutes makes half an hour. Okay, so I'm really thinking about this in terms of equivalencies. And if you just did this by sheer addition, 1/4 plus an additional fourth makes 2/4, and that simplifies to a half. Okay, but I really do like the context of putting it into the clock so that I can kind of work my way through what it's meaning. Now this one says a quarter of an hour plus a half an hour. Again, a quarter of an hour is 15 out of 60 minutes. A half an hour is 30 out of the 60 minutes. And that together is 45 minutes, which is 3/4 of an hour. And that looks like it is this one over here. So this is the picture that matches with this fraction addition problem. A quarter of an hour plus a half an hour is 3/4 of the hour. And then this must be, by process of elimination, the picture for number 3. And when I look at a half an hour, so 30 out of 60 minutes, where my minutes are my equivalencies here. So minutes are my whole. I'm looking at it as 60 minutes and 1 whole hour. And 3/4 of an hour is 45 minutes. And altogether, that would be 75 minutes or 1. Okay, well, 75 take away 60, because that's 1 hour, leaves 15 minutes left, which is 1 1/4 of an hour. Okay, so it's working out. This is the picture for number 1. This is the picture for number 2, and this one is the picture for number 3. And now in 4, 5, and 6, we're going to actually build those ourselves. So what I'm going to do here is I'm going to rewrite this as half an hour. And, okay, a third. Well, a third, if there are 60 minutes, and I split that into 3 equal pieces, that's 20 minutes. 20 plus 20 plus 20 makes 60. So a third of an hour is actually a 20-minute block. And that altogether makes 50 minutes out of the hour. So first, I'm going to go ahead and draw half an hour. Start at 12, go all the way to 6, and I see half an hour. And then I'm going to go ahead and build on to that, add to that 20 minutes, so 5, 10, 15, 20. And here is a third. So I'm noticing that this is a half. Okay, a half an hour plus a third of an hour, which was 20 minutes, gets me, okay, but now if I simplify 50 minutes out of the hour, so 50 sixtieths, that simplifies to 5/6. Well, in terms of the picture, 6. Can I turn this into 6 equal pieces? Yeah. if that would be 10 minutes apiece here. So let's see. This is 15. Here's 10 minutes right there. And then 5, 10 minutes right here. And 5, 10 minutes right here. Oopsie. Okay. And there I see that my, if I count by every 10 minutes, it simplifies to 5 6. 1, 2, 3, 4, 5 sixths of the hour, or 50 minutes. Okay, now let's do a half an hour. 30 minutes out of the hour. 2/3. Well, if 1/3 was 20 minutes, then 2 of those is 40 minutes. So 40 out of the 60. And altogether, that is 70 minutes, which is 1 hour with 10 minutes remaining. And so I see that my answer here is going to be 1 1/6. And my picture then, I'm starting with a half an hour. So here's my first hour. Okay, represented with this first clock. And I went half an hour. And then to do 2/3, well, first I'll start with 20 minutes. 5, 10, 15, 20. That's 1/3. Okay, but I have to keep going. So I'm still going past this. And that's 10 minutes, but then I need an additional 10 minutes over here. 5, 10. Okay, so something of the sort. And okay, where this was 1, this plus that made a 1/3 sector of 20 minutes. And then if I look at this and see that this is 1 whole hour plus a 1/6 of an hour, I go 10 minutes, 5, 10, 10 minutes, 5, 10, 10 minutes, 5, 10. Okay, and there are my 1/6, just so that I can visualize the fact that 1 hour and 10 minutes is 1 1/6 of an hour. Okay, and now, ooh, subtraction. Now that's fun. So 3/4 of an hour, 45 minutes out of 60 minutes. And then 2/3 we said was 2 sets of 20 minutes. So 2 sets of 20 minutes is 40 minutes. And of course, that will leave us with 5 minutes out of the 60 minutes. And that actually simplifies. If I scale down by 5, or take every 5 pieces and glue them into 1, that will become 1, and I think that will become 12. Okay, so let's take a peek at this. Starting with 3/4 of an hour. Okay. Got it. And then I'm going to be taking away 40 of these minutes. So let's suppose I do that. I'm going to do that in blue. Why not? So I went 3/4 of an hour. Now I'm going to take away, I'm going to wind back the time, 40 minutes. So leaving just 5 minutes. Okay, so I'm actually going, I went this way clockwise, and now I'm winding back the time just so that we see it. And all of a sudden these minutes have been taken away from us. And now what I see, okay, I'm going to have to color this one. This is what's left, so I'm just going to make it a little bolder there, is 5 minutes. And as 1/12, that actually means, oh, okay, this is actually helpful. Because if I think about this in terms of hours, there are 12 hours, and this is from 12 to 1, so one of the hours, and I can think of this as 1/12. Okay, so a couple of remarks to add and subtract fractions. we need to think of it as an equal portion. I used an hour because I like thinking of time and money, but money doesn't necessarily lend itself well to thirds. So I use the clock instead because 60 is divisible by 3 and by 2 and by 4 and by 5. So to add subtractions, we need the same portions. And that's what I was thinking about when I thought about these problems, is what could I portion up in a lot of different ways. Or, oopsie, equivalent fractions. Okay, when I say same portions, of course, the most common terminology for that is common denominator. Okay, and then my next remark is for our process. The process that we are taught and that we use, the process to add and subtract fractions just without pictures is, okay, if we start with A bths, or A over B, plus C dths, or C over D, then we find the common denominator, or we find out how we can cut it into equal pieces. Well, this can be scaled up by D, and this can be scaled up by B, and that would make this AD pieces out of DB pieces, plus this one scaled up by B, so CB pieces or BC pieces, however you want to say it, and out of BD pieces. Okay, and then we would add the numerators and keep the denominators, because remember, the denomination or the denominator is how we split it up in order to be able to have them be common or have that commonality so that we could take it away. 45 minutes, take away 40 minutes, as opposed to a half and a third or a quarter and a third. If I'm taking away a third, I don't have it split into thirds, I have it split into quarters. So I needed to be able to find some commonality in order to take away. Now, to use your calculator, there's a couple of things you need to know. If we are doing the problem 5/7 plus 4/5, for example, so random example, then what you need to do is satisfy the order of operations. So you're going to need to type in 5 divided by 7, or if you are using your MathFrac, your TI 83 or 84 that allows you to type in fractions as they are, by all means, go ahead. But if you don't know how to do that, this is what we would actually hit. And then we would do enter, and then, in my opinion, go to math and then to frac and turn this answer into a fraction, please. So fraction answers, please. And that's because then you don't have error, rounding error. So it's one thing to be wrong a lot. It's quite another to know that you're making yourself be wrong and just choose to do it anyway. All right, let's take a peek at multiplying fractions. Sandy and Priya have to rake and mow their lawn. They've been instructed to rake, and the raking has to happen before the mowing. Sandy is the raker, Priya's the mower. And if Sandy rakes a third of the lawn, and Priya has mowed half. So she's raked a third, and Priya, she's raked half of that. Okay, so I'm going to draw this out actually. How much of the lawn is done? Okay, here comes my lawn. It's a rectangular lawn. Go figure, huh? And at first we start with the fact that Sandy has raked a third of it. So let's break this into thirds and say that's what she's raked. And then it says that Priya has mowed half of that. Okay. Priya, former student of mine. Sandy, my aunt. Okay. So in the end, how much of the lawn is raked and mowed? A sixth. So half of a third is 1/6. Okay, now number 2 says write the English translation of this multiplication problem, and that actually is half of a third. So this multiplication problem represents half of a third. Okay, show that 1/2 times 2/3 on each of the following, show this operation on each of the following holes. Got it. Sure. So here's this is like my rectangular lawn all over again. Except this time I'm going to do it a little bit different. Here I did thirds vertically and then I did half of that down the center here. But let's suppose for fun I set this up as, I'm starting with 2/3 this time. So I'm going to shade 2 of these thirds. And then I'm taking half of that green stuff. Well, there's 2 chunks here and they're equal pieces. So I can just go like this and say, okay, I've taken half of it. I have taken half of that green stuff, which was 2/3. And that means what I've gotten is 1/2 of 2/3 is equivalent to 1/3. Okay, let's do it again over here. Now I'm going to, okay, let's see if I can draw thirds in here like a peace sign. Vertical ish, not an exact peace sign because that has a line down the middle. But anyway, okay, I'm starting with 2/3 again. And now I'm going to interpret this a little bit differently, and I'm going to say, let's suppose I take a half of each one of these thirds. Okay, so I'm going to go ahead and break this. Each one of these is going to get split in half. Split in half. Split in half and split in half. Okay, so I have cut every piece in half. And now I am going to take half of this third. Done. So remember that was my third. And then here is my other third. And I'm going to take half of that third. Okay, so I just took half of 2 of the thirds. And now what I'm noticing is that if I look at those purple lines, I'm still left with a third. Okay, but now I kind of viewed it as this. Those purple chops turn this into sixths altogether. So 1/2 times 2/3 generated 2/6. 1, 2, 6 equal pieces, which is equivalent to 1/3 if you look at the purple. Okay, now let's take a peek at these stars. Remember here, one hole is 24 stars. Okay, I had to squeeze it in there. And then if I chop this into thirds, okay, so here are my thirds. 1/3 of this whole set is 8 stars. Okay, and I'm starting with 2 of these. So I'm going to go ahead and circle this one and this one. I have 2/3 of the whole thing, and 2/3 of the whole set is what, 16 stars? Okay, and now I have to take half of that. So when I look at half of the circled business, I see 8. So I see 1/2 of 2/3 is actually equal to 8 out of the 24 stars, which simplifies down. Let's see. Take 4 pieces and glue them together, then that would become 2 bigger ones. Take 4 pieces and glue them together, then this would become 6 bigger ones. 2 6. Take 2 pieces, glue them together, become 1. Take 2 pieces, glue them together, then we have 3. Okay, got it. So it ends up right back to 1/3 of the whole set being 8 stars. Okay, and now let's take a peek at this. $33. Okay. Right off the bat, I think to myself, what is 1/3? 1/3 of $33 is $11. 2/3 of $33 is then $22. Okay. And so now I look at this and I'm like, all right, we need half of $22. Half of $22 is $11. And that's what we end up with here. So if we are doing half of 2/3 and 2/3 was $22, then half of that was $11. Okay, another way I like to think about this problem is that when I look at $11 here, we're really thinking this is $11 out of the $33, and that simplifies to, of course, 1/3. So regardless of how you view it, in all the different holes, if you take a half of 2/3, you end up with 1/3. And there are various different representations here for you to latch onto. Okay, now this is pure computation, and I'm going to compute this just arithmetically, and then you should also use your calculator in order to work these out, in my opinion, too. Just to remind you of how to do this. So 2/3 of a half, so now we're looking at a half, take half of these things and then take 2/3 of it, is 2/6, which simplifies again to 1/3. On your calculator, you would type in 2 divided by 3 for 2/3 times, and then parentheses, 1 split into 2, or 1 divided by 2, which is a half. Okay, so 1 split into 2 pieces is a half. 2 split into 2 split into 3 pieces, and you would get 2/3. I was just thinking about this differently. It's fine. And nonetheless, once you entered that into your calculator, you would hit enter in order to generate 1/3 as your answer. 1/3 of a half. Take a half, split it into 3 equal pieces, and then the other into 3 equal pieces, and you end up with 1/6. I do like to think of it as, I like to think of this one as a picture. So starting with a half, right? And then splitting that into thirds. And then right here, that would be our piece right there. 1/6 is what we end up with here. All right, 1 1/4 of 2/3. Okay. Now, so to me, when I interpret this, I'm thinking, okay, this is one complete set of 2/3. So one complete set of 2/3. Plus, in addition to that, 1/4 of a set of 2/3, which is a little bit awkward, I know, but still. And now one of these is just 2/3. But all of a sudden here, I can multiply, and 1/4 of 2/3 is 2/12. And in order to add thirds and twelfths, I'm going to need to find some commonality. So I'm going to go ahead and scale this up. Okay, so chop this into more pieces, make the pieces smaller, but more of them. 8/12 and 2/12 makes 10/12, which can be simplified and scaled down. Take every 2 pieces and join them to become 1. Oopsie, that's supposed to be a division symbol. Take 10 pieces, take every 2 pieces and glue them into 1. That brings it from 10 to 5. Take 12 pieces, and for every 2 pieces, glue them into 1. Now you have 6. 5/6. Now, on the calculator, be careful. This problem would really be 1 in addition to 1/4, which, by the way, we would have to rewrite like this. Okay. So 1 in addition to 1/4 times 2 split into 3 pieces, or 2 whole split among 3 people, however you want to think of 2 divided by 3. Okay. Let's take a peek at this one. 1 1/4 of 2 4/5. Okay. Now our life is getting a little bit messier here, so I'm going to go through instead of breaking it into one set of 2 4/5 and 1/4 of a set of 2 4/5 and then moving on from there, I'm going to go ahead and go through the arithmetic form of this problem. So I'm starting to notice that if I'm multiplying 2/3, I'm finding 2/3 of a half, and I multiply the numerators. 2 times 1 makes 2, and 3 times 2, so that in multiplying the denominators, 6ths, I end up with what I'm really supposed to end up with in terms of the pictures and the representation and the reality behind it. So I'm going to go ahead and use the algorithm or the process instead of the actual pictures now and breaking it into all of its bits. So here we go. I'm going to turn this into an improper fraction. 1 whole has 4/4, so now I have 5/4 because I had 4/4 plus an additional 1/4, and then this is times, well, 2, I have 2 wholes broken into 5 pieces each, that's 10, and then in addition to that 4 more pieces, I have 14/5. So this would be 10/5 plus 4 more fifths. And now I'm actually going to go ahead and scale down. Excuse me. Sometimes when I talk too much, I yawn. Okay. I'm going to go ahead and scale down to simplify this before I even move on to the next. So, well, maybe I'll come back to that. So I'm going to use my algorithm. 5 times 14 makes 70, and 4 times 5 makes 20 pieces. Okay, now I can scale down by 10, I feel like. 7/2, which is 3 1/2. If I had gone back here, I would have made my life a little bit nicer. Scaled down by 5 immediately to simplify, and then what I would have had is, let's see, this would have been 1/4 of 14, and then I actually could have scaled down again by 2. Okay, and remember that is just the act of taking every 2 pieces and gluing them into 1. That would have left 2 if I had started with 4, and if I start with 14, take every 2, glue them into 1, I end up with 7. Okay, which works out. So I can scale down in the middle of a multiplication problem if if I want to. Okay, some remarks. A quick way to multiply. Is to take A beats times C deets, or A divided by B times C divided by D, and multiply the numerators, A times C, and multiply the denominators, B times D. Okay, and that really truly does work, as we saw with so many examples previous to that. And I'm just going to leave it alone. I do want you to see that in the end, we end up with a common denominator, or many times when we're doing this and we look at a half and 2/3, right in the middle, we actually did generate a common denominator between these two and then simplified. It's just the action is different than addition, right? Addition is adding to, and subtraction taking away. And when we're adding to and taking away, we like to have everything in common. This act of multiplication, of taking a portion of something, or however many of something, also likes to have some sort of commonality in the process. Okay, but the quick way is that the multiplication just lends itself straight up to giving you that common denominator. Suppose we multiply mixed fractions. Okay, for instance, 3 2/5 times 2 3/4, for example. Well, that is actually easier to turn this into improper fractions, 17/5, and that would be 11/4, and just go ahead and use our quick way to multiply. 11 17s and 4 5s. Okay, and then go about our business to simplify. When we see, okay, now the meaning of that, when we see something like 1 1/4 times 2/3, this really says one whole set of 2/3 plus a quarter of 2/3. Okay, so 1 1/4 times 2/3 is one whole set of 2/3 plus a quarter of a set of 2/3. Calculators require parentheses. That is my next remark. Otherwise, they will not know the order of operations. So, very similar to that scenario where we did what, 1 1/4. This would be 1 plus 1/4, and then times 2 divided by 3, enter. Okay, and then my last remark before we hit division is this. People prefer the simplest forms of fractions because they're easy to understand. I've said that before, and I'm going to actually say it again. And that is why we are constantly scaling up and scaling down. So people prefer simplest forms of fractions because, that's my shorthand for because, they're easy to understand. Okay. In the next video, I'm going to talk about the division of fractions.